Gabriel. Hi, I'm Tashmika.
Hi, I'm Khalid. Hi, my name is Krishna. And we are ocean coders.
The challenge we got is to build a robot that can bring the technology of the sea bed.
So we decided to make a robotic arm and assemble it with a camera. Whenever the camera sees this any plastic or trash in the ocean, the robotic arm will pick it up. Our design. So first we used the DSE CAM 32 to identify the object. Next we used a model that makes a data for the when we see the object the data is in use and it controls the servo motor and the servo motor gets from the correct position to the robot. First, I want to ask you guys some questions. Does anyone want to answer me? How much trash do you guys think there is in the ocean? How much pieces of trash? Not like tons.
Maybe 230 billion tons.
There's 5.25 trillion pieces of trash in the ocean.
And then get to that. How much trash do you think? How much trash in weight do you think has been removed?
There are few volunteers working like sea reports. At least in CLUC, I think some website showed 500,000 something. I forget.
It's the answer is 11 million metric tons.
So that's why us ocean colors want to clean the seas. Okay, system stuff. First, so we use C code and C++ code. We engineer this code in Arduino IDE. We use Edge Impulse, which is behind the scenes uses TensorFlow to get images and make an object detection AI. We share the code in GitHub and Git, and we also use Windows and Mac computers for our operating system, and we use our innovation also, because we use why do you think we use the robotic arm as a conveyor belt or like the ideas the other teams use? Quick guess?
Anyone guess? I don't know that all the time. So.
Oh, okay. I'll give you one more hint. We'll also be using this robot in the deep seas, not by floating on the ocean, because we realize lots of trash are also in the sea, and that can also hurt living creatures. Most of the stuff I saw on the internet, there's some that go in the deep sea, but most of the stuff I saw on Google and like example Team Seas, they use a boat on the surface of the water. I saw pick up garbage like a conveyor belt. Okay? So then now I would ask you again, why do you think you would be using a robot instead of a conveyor belt? Oh, sorry. Why are we using a robotic arm than a conveyor belt? Any ball? Okay.
You could be selective with what you pick.
Yeah, but okay, yeah, I'll see that. But also, example. Yeah. Yes.
So I was saying instead of picking anything up from the surface, you're kind of adding it from the bottom. So you're going to kind of add it to Is it? That's why you use
Yeah.
hammer?
Yeah, because we need to dig into like sand or rock surface to grab it. Because if we use a conveyor belt instead of smooth surface, right? It's like, tank wheel, it basically rolls, then it'll go up and down the stuff, so it doesn't pop, pick it up. Okay?
Human collaboration. Most of these were also used for communication as well. First of all, Discord. Discord is a platform that is mainly used for text messaging and also video calling. Speaking of video calling, we also have Zoom and audio call. Audio call is really useful for if you have something where you need to do it last minute, but it can also be good just in general. But Zoom, you can schedule a meeting and just talk in general. Also, we have mail, email, Gmail, and WhatsApp. Both of these are really good for last minute and for normal talking in general when you have some time. But emails, usually they don't have a lot of notifications. But WhatsApp is usually more reliable and used. But DevPost. If you don't know what DevPost is described as the home for hackathons.
Okay, it's time to talk about the advantages and disadvantages of the things we use in our projects. First, I like to start with Etching Pulse. Etching Pulse is a platform that you can train yesterday to have. The advantage of using it is putting communication signals. Sometimes it's having this communication signals underwater. And the disadvantage is that etching pulse is a torch and the less flexibility with things. ESP32 can. We mostly we use ESP32 can because it's cheaper plus it's easier for us. But the quality of the images are low. Server is a common thing uses in robotic arms and things like that for hard, a little bit big weight. And the positions and angles, clockwise and counterclockwise. The disadvantage is it's slow, but it's still perfect for our project. Robotic arm with 6 hours. Robotic arm is the thing we mostly use in our project. Because it has 6 hours, the accuracy is good. But it's gives a challenge for all to do what we give from the signal of the ESP32 cam. Arduino IDE is the website we use to code ESP32 cam and the robotic arm. The advantage of using that is Arduino IDE have free libraries which have on for that. But the compiling and uploading takes some time.
Real-world challenges can be very difficult to deal with, but we've made a list of most of the main things that we might have had to deal with right now, and also eventually if we add it to the summary or when we add it to the summary. Our first real-world challenge: high pressure under the sea. High pressure under the sea can cause a lot of stuff, including explosions, implosions, and just a lot of shaking in general that can disconnect a lot of wires. So we want to make sure that doesn't happen by finding the right parts and wiring it in a good way. Next one is corrosive effect. Corrosive effect is basically the irreversible damage caused by a substance. So if it's irreversible, it's going to be very hard to fix or possibly unfixable. Worst case scenario. SME. SME is small, medium enterprise. Basically what it means is that we're not a very big company, or we're not exactly a company yet, but meaning that we don't have that high of a budget. We can't do exactly crazy things that can help the entire sea, because it takes time. We don't have that kind of budget, so it can be hard in some scenarios. But power management. Power management can be really hard to do when you talk about wiring. When the wires disconnect, we have to make sure that all the wires are connected and they're working properly. Because sometimes if it uses too much power, it can fry the battery of a laptop. Garbage weight. Garbage weight meaning we made a robotic arm, right? So when it picks up, if the thing is too heavy, or if the garbage is really heavy, it'll be really hard for the robotic arm to move at a good pace. It'll start shaking. It'll not only because of the pressure, but also because of the garbage weight. It'll start like freezing here and there. And the more garbage there is in the garbage disposal of the submarine, the heavier the submarine will be, and the harder it will be to float. Finally, communication latency. What it means is that if we're cleaning the deep sea, it's going to be really hard to communicate if they're that far into the sea. So it's going to be really hard to communicate. For example, have you ever wanted to connect with someone or call with someone that's really far away and it's really laggy? That's communication latency. It's really hard to connect with someone that's really far away.
Before we do the Q&A, we would like to show you a little demonstration. So we did have problems connected to the ESP function. So what I'm going to do is I'm going to demonstrate. I'm going to show this camera a plastic logo. It's going to detect the plastic right here. And then Gabriel and Kashmika will show you by moving how it will work by moving the robotic arm. So right now, it's not printing anything. So it just says object detection bounding boxes. It doesn't see anything. But now, when I show the plastic,
Yeah. Miss Vida, can you plug the computer so they can show the code?
Once I show the plastic, it prints plastic.
You can plug the computer so the code will be visible to the judges.
Okay. Guys, wait. We are going to connect this computer so the code will be. No. Just take note of that, so don't worry. Okay?
So innocent.
Connect the computer.
We need to keep the project just for that. To show things.
One more thing, if you see on the side of the plastic, it will show some coordinates of where the object is, height 8, width 8, y length 48, x length 64. So using this, we can use precise observability because that's its special ability to get precise angles. Using that, we can get the object and picks up the garbage by a precise angle with all of the 6 server monitors. So now Gabriel will show you how it's going to be the hack.
So this is the robotic arm that we'll be using.
You're blocking your sound.
I think Miss Vida, they are blocking the arm, I think.
Blocking what?
They're blocking the arm.
From the view of that, okay. They're in the side.
Gabriel, move out of
Side,
the
so that is going to
Sorry
be
about
the arm.
Now we will open the Reno IDE and now plug this in.
inside the muscle.
In certain ways. For example, if you wanted this plastic bottle that we used for the camera picture. You have to be careful though, because if it gets your hand, it can hurt a lot.
They have to experience that.
We don't have a precise location yet, but like Krishna said, there's a cord that's here, and now we have to use the ESP now function to connect to the Arduino.
So this is really cool.
What they are trying to say is like they are actually copy paste the value they are doing, like the integration is broken because like they had so much of challenges, ESP restarting and all, so they could do the integration. So now manually they take that value, they put this one as an input and do it. So in future they had to make it that value classic directly, right?
But one more note I would say is even though this wasn't that successful in the hackathon, at least I learned so many things, and I hope my other teammates also learned so many things about the ESP32 cam and the robotic arm. Okay, questions in here? Okay, so right now this was a demonstration, but later on we were going to use a submarine, okay, attached to maybe like the sides or the top, and it's going to move around, and later on with the distance of where the submarine is, and when it sees the garbage, it will move to that distance and pick up the garbage, and then it's going to have a home position and resets it, and it drops it into like an open box container.
This robotic arm will be mounted on top of the submarine.
Yes, or the side. Any other questions?
Did you think about how to handle the pressure?
We are still thinking about it, but
Like China is developing substation in the deep sea.
No.
Would have a big role. You're asking about the garbage weight pressure or the sea pressure? Or sea pressure.
we would know right now, to be honest, I really don't know. But if we wanted to go deeper into that, we would go and search up on ourselves. Like you know how submarines are built, right? They would also like check. So I would be like finding the same structure like that to also implement that. Like same design.
Submarine units can
Yeah.
higher, like for
Yeah.
or putting something. But this pressure is like when the sea pressure service, and also the pressure will change depends on the pricing, right? So you will have a lack of communication from top to the bottom. So when that happens, yeah, there's a chance to blast also. Because already happened in real world. So because sometimes the communication doesn't work well, and when the pressure goes, depends on the timing change, the submarine blast. That's practical. So. Any other questions?
I'm not sure if you guys talked about it, but like, how does it know, like the camera know, what's cache and stuff? Do you guys like use an AI model or make one yourself?
So basically, we're not using an AI model. It's something called Edge Impulse. I learned about it by watching lots of people doing it on with ESP cameras. It's behind the scene is also TensorFlow, but at the same time, it's more easier to use and more like it's basically pressing buttons and taking pictures and just labeling the pictures. That's the most easiest thing for that. Yeah.
Okay, so I was gonna ask you guys, not like a question, like a technical question. I just wanna ask you, what inspired you to actually go for the sea edge instead of going for, let's say, like something in the ocean or something in the coastal region, something like that? What inspired you to go to the sea edge?
Because for the floating garbage, there's already some things like sea cleaning, like projects going on. That's why we think to go to the sea bed instead of like floating things.
Thank you.
Also, one more thing to know: if you didn't look on like maybe like Google or anything, I think this is also one more thing I just want to say to my team. I never saw anyone do this same project on no tutorials, no nothing. So we did our best to try to do it on ourselves, and we tried our best to build and everything. But I've never seen any video with the ESP cam controlling the servo motor, the robotic arm. I always saw like ultrasonic sensor. That's what also inspired us to do the robotic arm too. Yeah. Any more questions? Yes, I think it's a bit hidden for you guys. There's one black here that controls the claw. There's one here, okay, that controls the like the twisting of the wrist. There's one here. There's some extras. One elbow, and one on the shoulder, and one for the whole leg. Yes. No, we only talked about single ones, right?
No, maybe.
And like these, right?
The first model is like for explain is for inside the robotic arm there's models. That's why we firstly put a one model and explain it, and after that put the robotic arm.
So basically, he's like, yes. So wait, where's the slide? Okay. So, do you mean this one? Oh no, this one. Okay, so I'll explain. This is a servo motor, but we said this image that one of like all the servo motors would be using the data converted to the robotic arm. This would be the output, I would say. So there's no like two servo motors. Inside this is a servo motor. That's why we put this, so then you can see what's in it. Get it? Okay. Thank you.
I have a question about the arm control. So you're using several motors to like 6 of them to control the arm. How are you planning to like translate the actions from the positions that you're taking as an input?
Do you mean like how do you expect us to control it?
Yeah, automatically.
Well, automatically we use the ESP32 camera to detect and see everything that's in its way. But for now, when we didn't have it attached, we use the serial monitor that you would see from our
Yeah, sorry.
I think what he meant was how we do it. Basically, this will see the object, and then it will send it to our there's an ESP now function which sends it to another ESP32, and that ESP32 is connected to the Arduino, which will tell the servo motor the position, and the servo motor will come and get the object.
Okay, so how is the Arduino going to be like, what is going to be the logic in the Arduino that is going to...
So most likely it's mathematical thing. Also, I would also show one more thing. I think when we are showing this serial monitor, it's showing the coordinates of each
It's not shared.
object.
And also, I repeated what the artist said, you guys will put the and when you take a picture, from the distance and all, you are passing the data to the servo motor. For 6, you are synchronizing to the 30. That was your question, right?
Yes.
How the data will be passed and like it's going to that's correct garbage with the ants, right?
Exactly.
Synchronize between the 6 motors. Yeah, that was the
Yeah, with in the ESP cam is going to identify like the length, the height, and everything. Earlier showed in the serial monitor, it showed like each position on side of the plastic. And using that position, we add to we send it back to so ESP cam has two things, the ESP cam, the cam, and the ESP. So first the cam gets the thing, the garbage, sends it to the processor, and then it does the calculations and gets the coordinates, and using those coordinates it sends to the servo motors for the action.
Okay, so using the coordinates, you can you can get the XY coordinates, the Z coordinates, the width, height,
Yes.
yeah. So using all those inputs, you put it to the controller, you send it to the controller, and the controller has to give an output to the motors that tells it how it's gonna grab and lift it up. So it has to do all the calculations. The controller has to do that. So how are you gonna implement the logic?
You know they, shall I give a small
Yeah.
mapping data?
Oh yes, I can. Yeah. So, we're using mapping the data from the object. Like
But
that's
the thing is, you got all the inputs.
Yes.
How do you know whether you have to grab it or leave it out? No, that particular code, how are you going to process it?
In this code, it basically detects the object and it only says the coordinates when it detects the object. So when it shows the plastic, it will put plastic. And when it gets the plastic, it will send it to the Arduino. Only then it will send it. Anywhere else it won't send it, which means the handle.
So whenever you receive the coordinates, you grab it.
The size are critical, so with a lot of
Oh,
environment
it's not
changes
plastic.
and
But it won't grab unless it's plastic. So you don't really release it. So in the edge code, this is also what we're pro about edge code. You won't have to print every single item. If you only print those items, you will only be doing it.
they do. Many ships I have seen rescue missions that we have but they can do this.
So once he grabs it, we have a home coordinates he said before. It's in a box that in the submarine there's like a trash bin basically, and that will set that as a home coordinates, and it will first get those coordinates, go to those coordinates, grab it, move it to the home coordinates, and then throw it.
Finally answered.
Okay, so for the mapping, are you going to manually do the mapping, or are you going to train another model to map it for you?
It already does the mapping using the coordinates. We just need to send it to the server motors.
How does it do the mapping?
Like we use a variable called switch for do that. Like using switch, inside switch, we put specific things like 1 equals specific degrees. Like for now we put 5 degrees, and like that we go until 180 degrees, and if it's like we call the ESP32 cam to to find like 1, 2, 3 or like that, and using the numbers the robotic arm will move.
Okay, thank you.
So I have a question. So when you get the coordinates, let's say for example you get a coordinate for like a plastic bottle, right? Let's say if it's too far and your arm can't reach it. Does your logic have does your code have the logic to detect, okay, this bottle's too far, we can't reach it, we should not go for the bottle, we need to first get closer, and then only when it's in range we go for the bottle. Can you talk about that?
So if it's like what you said, yeah, that would be future improvement. If it's not in a certain range, the ESP32 won't even detect it. So it won't detect it. We have it so if it's not close enough for the arm to grab, it won't detect already.
Okay, so basically sometimes we take the arm and go. If it is far away, it's not going to send any signal. So they have a logic like if it reaches 100 centimeters or something only, it will start to get. If it 100 centimeters is get trash, then only the input signal will go. Otherwise there's no input signal. Environmentally okay, right? It doesn't damage the environment.
Environmentally okay. It's cleaning the environment at the same time, while it is also helping the environment. But we don't, obviously fish can't just like go into it. But if fish get caught in like the claw, because like if they swim into the claw, that's the only issue that's like possible. But that's the thing with the ESP30 kind of won't protect fish. That's
Their question is what is eco-friendly or not? Like the materials you use, right? The materials you guys use and like really harm the environment or don't harm the environment? Their question. So I was thinking about the material and all those things. So like e-waste, right? Like she said, e-waste is already harmful to the environment. So how you are going to handle those things to be more eco-friendly?
how we're gonna handle it to be more eco-friendly. Well, it kind of maybe it depends on how we attach it to the submarine. That could also be like a factor.
People think it's the big goes into the water, you know, how like there's fuel and all of that stuff.
Oh yeah, kind of like pollution.
So sweet.
Yeah, batteries are eco-friendly and it's powered by a 9-volt battery, so and it's reusable, it's chargeable. So yeah.
Because submarine, yeah. But submarine is out of their scope because submarine they will do anything.
That much rich.
Robotic arm only they are doing.
Now rich enough to rent a submarine.